Hi guys, in this video we are going to discuss how to draw a phase diagram for RLC series circuit. However, you don't need to memorize these things, but why I'm doing this video is actually you need to know whether if you do these sums individually, you can't understand what's happening in overall. So I need to explain that in one whole video. So I'm going to do this video. Also, if you like to watch any other videos from Expert Tutor, I have given the link in the description, so you can always watch that. Also, if you are new to this Expert Tutor channel, please don't forget to subscribe. Okay, without wasting our time, let's move to the main part. Okay, over here I have already drawn a simple diagram. The capacitor and the resistor as well as the inductor are connected in a series alternating current. So the thing over here is actually we knew that there might be some instances where XL greater than XC, and in the second case we are going to look at XL equals to XC, which simply means the reactance of that L, the inductor, would be when the reactance of that inductor and the reactance of that capacitor are equal, and we are going to have another case where the reactance of that inductor is less than reactance of that capacitor. So now we are going to discuss all three cases. Before that, what can we write, whether we can try to write any equation for this circuit. Actually, we knew that we can directly write an equation, which simply means we can use the Kirchhoff's voltage law, and directly write the voltage across these three elements would be equals to VR plus VL and VC. The voltage across the capacitor and the voltage across the resistor and the voltage across that inductor, the total of these three would be equals to voltage, the total voltage across these three elements. However, we can write another thing also. It's going to be the the current would be same for these three. So that's the main point. As these are connected in the series, we can tell it's going to be the same. So okay, let's move to the first value, but be careful about the next following steps. So first of all, let's multiply this. Actually, they have given that XL is greater than XC. Before drawing the phase diagram, we need to figure it out whether the voltage between the capacitor or voltage between the inductor is higher in this case. How to figure that? So when we are drawing the phasor diagram, actually we are going to draw the phasor diagram for voltage as well as current in these three cases. So when we are drawing for that, actually we knew that I is going to be same for that. So we are going to take the I as the reference for these three. So when we are considering about the voltage for these three cases, we can directly tell voltage might be differ when that XL is equal to XC and XL is greater than XC. So we need to figure it out over here whether the voltage in that inductor is greater than voltage in that C, the capacitor, or it's less than the voltage in that capacitor. So how we can find that is, we can directly multiply this by I. If I multiply like this, I'm going to have a value of IXL greater than IXC, which simply means the voltage between that inductor would be voltage between that current. Be careful, these values are the RMS values, which simply means root mean squared values of the current. I'm going to multiply it by I, and I'm going to get that answer in that RMS value. The VL is the RMS value and VC is the RMS value, and it's going to be higher. In another way, if I consider this one, the magnitude of this vector is going to be this one. VC is magnitude, or that RMS value. Actually, we called that RMS value as V magnitude of that vector. So if we consider this one, it's going to be the VC. Then this one, the magnitude of this one, this vector VL, right? So this is, we can derive this one using Ohm's law. So the next case, we are going to draw a phasor diagram for this case. If I draw a reference line, I can use that I as the reference line, because in each cases the I is going to be the same, because as it's connected in the series, I have already mentioned that the current would be same for these three elements. It's not going to change as this is in the series. So I have drawn like this I in the reference line. So let's take this direction as reference direction. If you like, you can mark it like this, reference. So the next part is, we can directly tell the VR is going to be, the voltage between the R is going to be in this side. So let's mark it in the blue color. If I mark it like this, it's going to be in this direction, reference direction. Actually, we can directly use this because when we are considering about the angle between the I and VR, the current in that resistor and the voltage in that resistor, the angle between these two phases would be 0. I've already studied that the phase angle between the voltage and current in a resistor would be 0. So we can directly use that. After that, we are going to draw, let's draw for XL. If I draw for the inductor, the L inductor, the voltage of that inductor is going to lead current. If you consider, don't just forget this VR. If I consider the inductor, we can tell the I is going to be the same for that inductor too, and the V part, the voltage part, is going to be 90 degrees from that. Actually, we have already learned that the voltage will lead that current in an inductor. So voltage is going to lead that current, which simply means it's going to be having a plus 90 degrees. So we can directly mark over here, it's going to be plus 90. Let's mark it like this. So it's in the plus 90, like this one, plus 90. So this is going to be BL. Likewise, we can directly tell the VC would be in the minus 90 degree with respect to this I, because we already learned that when we are considering about the capacitor, the voltage between that capacitor and the current between the current going through that capacitor will lead that voltage between that capacitor. The current is going to lead that voltage in a capacitor. So we can tell, don't consider these two. If I consider this I, it's going to be same to that capacitor too, as it's connected in the series. We can directly tell this. So after that, if we consider the voltage, it's going to be in this direction, because in this capacitor we already knew that the I is going to lead that voltage. In other terms, we can tell the V is going to lag the current by 90 degrees. So lag, which simply means it's going to be in the minus 90. It's going to be in this direction. So if I continue from this part, we have ended up in this. We have already drew this VR and VL, and these are vectors. So you can directly act from this part. It's going to be in the negative direction. However, we knew that it's going to be less than VL, so you can't draw up to this point. You can draw like this point. Let's say this is BC. So it's going to be VR, and it's going to be the VL, and this is going to be BC. Likewise, we can tell the resultant voltage would be in this direction. This is known as the phase diagram for this circuit. So this is the thing you need to know. So if we consider the phase angle between I and voltage, now it's going to be in this direction, which simply shows the voltage is leading the current. Actually, we have now used these three elements. However, in the resultant, we can see that the voltage is leading the current, so that we can tell it's going to be similar to an inductive circuit. So we can tell it this circuit as inductive circuit, because actually we knew that the voltage will lead that current in an inductive circuit only. So we can tell these three elements are going to make a circuit which is going to have a characteristic of inductive circuit. So we can tell this as inductive circuit. So these are the things you need to know about this. Actually, you don't need to memorize this one, whether how to use this and how to figure it out. Actually, if you know this one, you can directly draw a phase diagram like this and figure it out whether it's inductive or capacitive. So I'm going to move it out for next part. XL is equals to XC. the XC is known as is having a special name called resonance type because there are the inductor as well as capacitor. However, it's going to have a special characteristic of resistive circuit, which simply means it's only going to have VR portion in that the voltage and the current, the angle between these two phases would be 0 in a resistor circuit. Likewise, although there are C, R and L, the resultant voltage and the I would be in the same direction. So it's going to have a special name known as resonance. So you need to remember that name because they will ask the question and mention that it's a resonance circuit. So if I multiply these 2 by I, we can directly tell the BL is going to be equal to BC. So I can write it like inductive circuit. Here, over here, inductive circuit, I can write it like 60. It's just a short form. Okay, so BL is equal to BC. So now I'm going to draw the phasor for these two. So I'm going to draw the first for I. So I, and if I draw for VR, it's going to be in this direction. So this direction VR, and we need to draw for BL. So actually you can't change these two also. You can draw this VR first and you can draw the BC second. You can draw in any direction. As this is a vector, you should follow these three order. So if you write it like BL plus BR plus BC, you can start from BL and next you need to draw BR, and after that you can draw the BC and find the resultant. So you can move on any directions in any orders too. So next, after that, I'm going to draw the BL. Actually, we knew that BL is going to be leading this current. This current is same for inductor too. So we can tell the inductor's voltage is leading that current. So it's going to be in this direction. It's going to be BL. From that, I'm going to return to that 90 minus 90. So it's going to be in this direction because the I is in this direction, horizontal. So we can tell when the voltage is lagging the I, it's going to be 90 degrees downwards. So it's going to be in this direction. Actually, we knew that BL is equal to BC. From that, it's going to end up over here. From that, we can directly tell the resultant would be here. From this length, the resultant voltage, and would be equals to BR. That's a special thing. So we can tell it like resonance circuit, series circuit. Also, you can tell it's going to be having a resistive characteristic. So the general term is we are going to use that series resonance circuit. So if you draw for this part, you will be getting a circuit which is capacitive characteristic. However, there are inductor too. It's going to show a capacitive characteristic. That's why we are going to call this circuit as capacitive circuit. So the thing over here is just try to draw it in your own, so it would be more useful for you. So I'm not going to draw over here. So I think this video would be useful for you. If you have any doubts, please comment it below, and if you have any suggestions to my videos, please let me know. I can improve myself too. Thank you for watching.